Construction is full of big machines, but some are so strange, so wildly engineered, that they look like they rolled straight out of a sci-fi movie. These machines exist because ordinary excavators, bulldozers, and cranes simply can't handle the extreme jobs they were built for. From robots that walk on legs, to trucks that vacuum dirt, to machines that move entire highways in real time, these weird vehicles prove that construction engineering is far more creative and sometimes bizarre than most people ever realize. In this list, we explore 14 of the weirdest construction machines ever seen, and more importantly, why they exist. Each one solves a problem no normal machine can, and many of them still work today, reshaping mountains, forests, rivers, tunnels, and even city traffic in the most unexpected ways. The walking excavator, spider hoe, built to climb mountains. The walking excavator, often called the spider hoe, is one of the strangest and most impressive construction machines ever created. Instead of relying on wheels or tracks, this excavator stands on extendable legs that let it walk, climb, stretch, and balance on terrain where normal machines would instantly tip over. Built for extreme jobs like mountain roadwork, riverbank repair, forestry operations, and disaster rescues, the spider hoe exists because no other machine can reach the places it can. At first glance, the spider hoe looks like a mix between an insect and a construction robot. Its cab sits on a central rotating frame, while its legs, massive hydraulic arms, extend and plant themselves on rocks, slopes, and uneven ground. Each leg can lift, push, pull, and stabilize the machine independently. This gives the excavator the ability to step over obstacles, climb steep hillsides, and even stand with 2 legs on a slope and 2 in water. The entire machine moves slowly, but it moves with surprising control and precision. The idea behind the spider hoe started in the mountains of Switzerland and Austria in the mid-20th century. Traditional tracked excavators were too heavy and unstable for steep alpine construction. So engineers designed a lighter machine that used hydraulics instead of tracks for movement. That design evolved into the modern walking excavator, which can operate on terrain up to 70 degrees steep, conditions where no wheeled or tracked excavator can survive. What truly makes the spider hoe special is how it combines mobility with full excavator power. Its boom, stick, and bucket function just like a standard excavator, allowing it to dig trenches, lift logs, break rock, and perform precision work. But because the legs can reposition and brace the machine, the operator can set up stable digging positions on slopes that would normally be impossible. Many models also feature wheels on the leg ends, giving them the option to roll on flat ground and walk on rough terrain. Walking excavators are often used in emergency situations. When floods wash out roads or landslides block mountain passes, these machines can climb over debris fields and start clearing paths long before other equipment arrives. Their ability to stand in rivers makes them perfect for repairing riverbanks and installing erosion control structures. Some are even equipped with winches and extendable stabilizers for rope-assisted climbing. Even though the spider hoe looks strange, it represents brilliant engineering. It exists because construction doesn't always happen on smooth ground. When the job is dangerous, steep, muddy, or uneven, the walking excavator steps in, literally, to do work no other machine can. The road widening trencher, a machine that eats roads. The road widening trencher is one of the weirdest and most specialized construction machines ever invented. A giant mechanical road eater, built to slice off the edges of highways, carve perfect trenches, and widen lanes with stunning precision. Instead of a bucket, blade, or drum, this machine uses a rotating, chainsaw-like digging wheel, or conveyor-mounted cutter that literally chews through asphalt, concrete, and compacted soil. Watching it work feels like watching a giant metal beaver gnaw through a roadway, spitting debris onto waiting trucks as it creates fresh, clean edges for new pavement. The machine exists because road widening is normally a slow, messy, and expensive process. Traditional methods require excavators to hammer through pavement, haul away chunks, and then reshape the road edge. This causes uneven cuts, jagged edges, and massive cleanup work. Engineers wanted something faster and more precise, so they built a machine designed to eat roads in smooth, continuous passes. At the heart of the road widening trencher is its enormous cutting wheel or chain assembly, often several feet tall and lined with tungsten carbide teeth. As the wheel rotates at high speed, it bites into the edge of the existing road, slicing through asphalt like a hot knife through butter. The machine removes just the right width, 12 inches, 24 inches, sometimes up to several feet, depending on how much the lane needs to be expanded. A conveyor system immediately lifts the broken material and dumps it into trucks driving alongside, allowing non-stop production with no wasted motion. One reason this machine looks so strange is its offset design. The cutter sits far to one side so the operator can drive on the existing lane while the machine carves the shoulder. This allows it to widen highways without shutting down an entire road, making it invaluable for busy highways and urban projects where closures cost millions in delays. Its versatility also makes it unusual. The same machine that eats road edges can cut utility trenches, slice irrigation channels, or create foundations for guardrails and barriers. Some models can even cut through reinforced concrete, thanks to heavy-duty gearboxes and high-torque hydraulic motors. Operators say running a road-widening trencher feels like controlling a precision monster. The cab rides smoothly, while the cutter screams loudly, pulverizing the ground below. With GPS guidance, modern models can cut perfectly straight lines even at night or in poor weather. The road-widening trencher may look bizarre, but it solves a very real problem: how to widen roads quickly, safely, and with nearly surgical accuracy. It's a road-eating machine built for a world that needs bigger highways and needs them fast. The bridge-laying machine SLJ 900/32, the giant that builds highways in the air. The SLJ 900/32 is one of the strangest and most impressive construction machines ever created. A 580-ton steel giant designed to build elevated highways without cranes, scaffolding, or temporary supports, often called the bridge girder erector, or simply the segment lifter. This machine doesn't just help build bridges, it becomes the bridge while building it. Watching it operate feels like watching a mechanical centipede crawl across the sky, placing massive concrete beams with eerie precision. Built in China by the Beijing Wao-Joint Machinery Company, the SLJ 900/32 was engineered to solve a major infrastructure problem: how to construct long elevated highways in densely populated cities or mountainous terrain where cranes can't be positioned. Instead of lifting beams from below, the machine rolls across the already completed section of bridge, extends itself forward, and installs the next beam in midair. This allows construction crews to build highways high above traffic, rivers, valleys, and rail lines with minimal disruption. The machine is 300 feet long, longer than a Boeing 747, and moves on multiple sets of wheels mounted along its spine. When it reaches the end of a completed section, its front end stretches out over the empty gap, supported by massive steel legs that press onto the next pier. Hydraulic systems stabilize the frame, allowing the back end to lift and slide forward. It is a slow, deliberate ballet of heavy steel, but the result is astonishing. The machine appears to crawl across the sky. Once positioned, the SLJ 900/32 uses a giant internal trolley system to pick up prefabricated concrete girders, each weighing 800 to 1,000 tons. The girder is moved along the machine's internal rails until it hangs directly over the gap. Then, hydraulic clamps lower it precisely onto the supporting piers. Workers bolt the girder into place. The SLJ 900/32 retracts its support legs and the entire machine inches forward to repeat the process. Despite its unusual appearance, the machine is extremely efficient. It reduces the need for ground-based equipment, minimizes traffic closures, and drastically cuts construction time. It also increases safety by keeping workers off cranes and scaffolds. Today, the SLJ 900/32 has become famous worldwide thanks to viral videos showing the giant mechanical creature gliding above cities. It looks strange, almost alien, but its capability is unmatched. In a world that needs faster, safer infrastructure, the SLJ 900/32 builds highways in the air, one massive girder at a time. The tunnel-boring mole, a subterranean metalworm. The tunnel-boring machine, often called a mole, is one of the weirdest, most mesmerizing construction vehicles ever invented. Unlike bulldozers that scrape the earth or excavators that scoop it up, a TBM moves through the ground like a giant mechanical worm. Hidden beneath cities, rivers, and mountains, it quietly eats its way forward, carving perfectly round tunnels for subways, sewers, rail lines, and water systems. Standing beside one feels like standing next to a steel monster, a rotating metal face, a long, segmented body, and a trail of new tunnel behind it. At the front of every mole sits its most recognizable feature, the cutting head. This massive circular face, sometimes 20, 30, or even 50 feet across, is lined with dozens of hardened steel discs and cutting tools. As the head rotates, it grinds through dirt, rock, clay, sand, and even reinforced concrete. Anything in its path gets crushed into small fragments, which are carried away by conveyor belts running through the TBM's long internal body. Instead of digging one bucket at a time, a mole eats continuously, chewing through thousands of tons of earth without stopping. Behind the spinning cutter head, the machine stretches out in a long, worm-like series of connected segments. These house hydraulic rams, electrical systems, soil transport conveyors, and operator cabins. The mole crawls forward by bracing itself against the surrounding tunnel walls. Hydraulic pistons push the cutter head forward as the machine slowly extends. Each push advances the mole just a few inches, but repeated thousands of times per day, it can carve miles beneath a city with remarkable precision. As it tunnels, the machine simultaneously builds the walls behind it. Precast concrete segments, shaped like giant curved puzzle pieces, are brought in and placed around the new tunnel section. Hydraulic arms position these segments, lock them together with bolts, and create a sealed, reinforced ring. This process happens continuously, so the tunnel emerges fully finished right behind the mole's tail. It's like watching a mechanical creature dig its own underground highway and reinforce it as it goes. Because TBMs operate deep below the surface, they are equipped with sophisticated navigation and monitoring systems. Lasers, sensors, and computer controls ensure the machine stays on course. Drifting even a few inches could cause catastrophic alignment errors. Operators monitor pressure, torque, soil composition, and structural stability from inside a control cabin that feels more like the cockpit of a submarine than a construction vehicle. From the crossrail tunnels under London to deep metro systems in China and flood control tunnels in the US, these subterranean steel worms have reshaped the world from below. Strange, massive, and incredibly complex, tunnel-boring moles are among the weirdest construction vehicles on Earth, but they remain essential to building the cities of tomorrow. The bucket wheel excavator, the machine with a spinning mouth. The bucket wheel excavator, BWE, is one of the strangest and most unforgettable construction machines ever built. A steel giant with a massive spinning mouth, designed to chew through earth non-stop. Standing beside one feels like looking up at a moving building. Some of the largest versions stretch over 300 feet long, tower more than 20 stories high, and weigh as much as a small cruise ship. Yet, despite their size, what captures everyone's attention is the rotating bucket wheel at the front, a circular steel face lined with scooping buckets that tear into the ground as it spins. Unlike traditional excavators that dig one scoop at a time, a bucket wheel excavator never stops digging. Its wheel holds a ring of large steel buckets that bite into soil and rock with every rotation. As the wheel spins, the buckets fill, lift, and dump their load onto a conveyor belt system. That material is then carried through the machine's long boom and onto external conveyors that stretch across mines. The entire process is continuous, like a mechanical mouth devouring the landscape. BWIs are used mostly in massive open-pit mining operations, especially in coal and lignite mines where huge volumes of overburden must be removed quickly. These machines can shift tens of thousands of cubic yards per day, far more than any fleet of trucks and hydraulic excavators could manage. Their long booms allow them to reach deep into pit walls, shaving off layer after layer of earth with the smooth rhythm of a giant rotating saw. What's even stranger is the way these giants move. Despite weighing thousands of tons, BWEs crawl forward on enormous tracked undercarriages, often several sets of tracks working together. They don't move fast, but they don't need to. Their job is slow, steady excavation across huge mining faces. Operators sit high above the wheel in a control cab, navigating the machine with joysticks, sensors, and monitoring screens that track conveyor speeds, wheel torque, and structural loads. Inside the wheel, each bucket can hold hundreds of pounds of material, and the wheel can spin thousands of times per day. With every rotation, the machine slices deeper into the earth, shaping the mine like a sculptor working on an enormous canvas. Despite their strange appearance, BWEs are engineering masterpieces. Machines built for one purpose move unimaginable amounts of earth as efficiently as possible. Their rotating steel mouths may look bizarre, but in the world of mega construction and mining, nothing matches their appetite for dirt. The pneumatic pier driver, pile pounder, a giant hammer on a crane. The pneumatic pier driver, often called a pile pounder, is one of the loudest, heaviest, and strangest construction machines ever created. At first glance, it looks like a giant hammer hanging from a crane, and that's exactly what it is. This machine's purpose is brutally simple: drive steel, concrete, or timber piles deep into the ground to support bridges, seawalls, skyscrapers, and offshore platforms. But the way it works is where things get weird. Instead of using hydraulics or a swinging boom, the pile pounder uses compressed air to fire a massive steel weight up and down like a piston the size of an engine block. The heart of the machine is a giant cylinder mounted vertically above the pile. Inside the cylinder sits an enormous hammer, often weighing several tons. High-pressure air repeatedly lifts this hammer and slams it down with tremendous force. Each impact sends shockwaves through the pile, pushing it inches, or sometimes just millimeters, deeper into the earth. Over thousands of strikes, the pile reaches solid bearing layers, creating a foundation strong enough to support structures weighing millions of pounds. Mounted to a crane or a dedicated pile-driving rig, the machine is raised over the pile using cables. Once aligned, operators activate the pneumatic system, producing the unmistakable rhythmic boom, boom, boom that can be heard miles away. On large coastal projects, the sound of pile driving echoes across harbors and valleys, becoming as much a part of the job site as the machines themselves. The pneumatic pile pounder is especially useful on projects involving soft or unstable soil. In marshes, riverbanks, or loose sand, piles must be driven until they reach bedrock or compact layers underground. Other machines stall or lose efficiency under these conditions, but the air-driven hammer delivers consistent blows without overheating or losing power. One feature that sets pneumatic drivers apart is their simplicity. Compared to hydraulic systems, they have fewer moving parts and can operate in harsh environments filled with moisture, grit, and salt. That reliability is why they're used on everything from highway bridges to offshore wind farms. Some models are even mounted on floating barges, so crews can drive piles directly into the seabed. Despite being one of the noisiest machines in construction, the pneumatic pile pounder remains one of the most essential. Its giant hammer-on-a-crane design may look primitive, but its raw impact power makes it unmatched for building deep foundations. Whether on land or at sea, this giant pneumatic hammer continues pounding its way into construction history. The concrete slip-form paver, the machine that prints highways. The concrete slip-form paver is one of the strangest construction vehicles you'll ever see, not because of its size or speed, but because of what it creates. While most machines push, lift, or dig, the slip-form paver does something completely different. It prints highways. Watching it in action feels almost unreal. Concrete flows into the machine like thick batter, and a perfectly shaped road, smooth, straight, and ready for traffic, emerges from the back as if the machine were a giant 3D printer rolling down the job site. The way it works is surprisingly elegant. Fresh concrete is dumped in front of the machine by trucks. Augers inside the paver spread and level the material, ensuring an even distribution. Then the magic happens. The machine's slip form, a carefully engineered mold, shapes the concrete into the exact width, thickness, and profile required for the roadway. As the machine crawls forward, the mold continuously forms the slab, and the concrete immediately begins curing behind it. There's no stop-and-start process, no individual panels, and no need for forms on either side. The road is created in one long, seamless ribbon. Slip-form pavers ride on tracks, using GPS guidance or string lines to follow perfectly straight or curved paths. Advanced models can build multi-lane highways, airport runways, curbs, gutters, and even concrete barriers without changing the basic machine, just swapping molds. The accuracy is remarkable. Edges come out sharp, surfaces smooth, and thickness uniform. What used to take days of forming and pouring can now be done in hours. One of the biggest advantages of slip-form paving is strength. Because the concrete is poured continuously, it cures as one huge slab rather than separate sections joined with seams. This reduces cracking and makes the pavement more durable. Ideal for highways carrying thousands of heavy trucks a day. The machine also vibrates the concrete during forming, eliminating air pockets and improving density. Despite its size, the paver moves slowly, often just a few feet per minute. But speed isn't the goal, precision is. A small crew monitors the concrete consistency, checks alignment, and ensures the machine stays fed with material. When working correctly, the paver creates roads so perfectly smooth that drivers never think twice about them. Today, slip-form pavers are used worldwide to build everything from major interstates to airport runways and industrial yards. They may look unusual, but their ability to print miles of flawless pavement makes them one of the most important and weirdest construction machines ever invented. The LeTourneau tree crusher, a forest flattening tank. The LeTourneau tree crusher is one of the most intimidating, bizarre, and downright colossal machines ever unleashed on a forest. Built in the late 1950s and early 1960s, this monstrous vehicle looked like a cross between a military tank, a steamroller, and an industrial battering ram. Its purpose? To flatten entire forests in a single pass. Not cut, not push, not uproot, crush. With its steel lobes, massive drums, and unstoppable weight, the tree crusher was designed to leave behind a landscape as smooth as a freshly plowed field. The machine was the brainchild of R.G. LeTourneau, the legendary engineer known for creating some of the world's largest off-road vehicles. In an era when clearing land for roads, dams, and industrial projects meant weeks of chainsaw work, bulldozers, and burning brush piles, the tree crusher offered a radical solution. Remove the human labor entirely. Instead of felling trees one by one, why not build a machine heavy enough to simply steamroll everything? The result was a 175-ton beast powered by a massive diesel-electric system. Two giant drums, each taller than a person, sat beneath the machine, acting like compacting rollers. As the tree crusher crawled forward, these rollers crushed everything in their path: trees, stumps, roots, undergrowth, even boulders. The tremendous weight pulverized full-grown trees into splinters and pressed them into the soil. What remained behind was a flattened forest floor, ready for development or controlled burning. Steering the tree crusher was as strange as its appearance. The machine used articulated steering, bending in the middle like a giant hinge to change direction. From the operator's cab, perched high above the carnage, drivers had an almost surreal view. Towering trees collapsing like matchsticks beneath the machine. The forest canopy disappearing in minutes. When fully operating, the tree crusher moved slowly, only a few miles per hour. But its destructive power made up for its lack of speed. The machine's most famous deployment took place in Canada during a massive land-clearing project intended to prepare terrain for hydroelectric development. There, the tree crusher flattened thousands of acres of woodland. Crews found that while it couldn't handle large rocky outcrops, it could obliterate nearly every type of softwood and hardwood forest in its path. Though incredibly effective, the tree crusher had drawbacks. Its enormous size made transportation extremely difficult, and environmental concerns eventually pushed such machines out of use. Still, the surviving units, now rusting in remote forests or displayed in museums, remain awe-inspiring relics of an era when engineering dared to think bigger, louder, and far more destructive. The LeTourneau tree crusher stands today as a mechanical legend, a forest-flattening tank whose sheer scale and power will likely never be seen again. The telescopic handler, telehandler. The forklift with a crane neck. The telescopic handler, better known simply as the telehandler, is one of the strangest and most brilliantly versatile machines ever used on construction sites. At first glance, it looks like a regular forklift. But look again, and you'll notice the feature that makes it one of the weirdest hybrid machines on Earth: a long, extendable boom that works like a crane's neck. This single design twist transforms the telehandler into a lifting machine that can do the job of a forklift, a crane, a man lift, and even a small loader all in one. The magic behind the telehandler lies in its telescoping boom. Instead of lifting loads only a few feet off the ground like a traditional forklift, a telehandler can extend its boom 20, 40, or even more than 50 feet into the air. This gives it the ability to place pallets on rooftops, lift materials onto upper floors, or position heavy loads in places no forklift could dream of reaching. Whether delivering drywall to the 4th story of a new building or lifting trusses onto a house frame, the telehandler's reach makes it indispensable. Unlike a mobile crane, the telehandler is compact and extremely maneuverable. It drives like a rough-terrain forklift, equipped with 4 big tires, articulated steering, and the ability to tackle mud, gravel, and uneven job site terrain. Some models even feature 4-wheel steering or crab steering, allowing the machine to move sideways into tight spaces, or align precisely with scaffolding. This strange steering ability often surprises first-time operators. Watching a multi-ton machine glide diagonally like a crab never stops looking unnatural. Another reason the telehandler stands out among weird construction vehicles is its ability to swap attachments. Instead of being limited to forks, it can use buckets, clamps, man baskets, winches, and even hydraulic tools. With a quick attach system, one telehandler can switch from lifting pallets to scooping gravel to hoisting workers into the air, all within minutes. This makes it one of the most cost-effective machines on large job sites, farms, warehouses, and industrial yards. But the telehandler's design also comes with challenges. Because the boom extends outward, the machine's center of gravity changes dramatically with every inch of reach. Operators must constantly monitor load charts, angle sensors, and stability warnings to prevent tipping. Modern telehandlers include electronic limiters that prevent unsafe moves, but older models rely heavily on operator skill. Despite these quirks, the telehandler has become a universal workhorse. Its ability to combine the strength of a forklift with the reach of a crane makes it one of the strangest yet most brilliantly practical machines ever invented. A true forklift with a crane neck that reshaped construction forever. The suction excavator, the vacuum truck that eats dirt. The suction excavator, often called a vacuum excavator or vac truck, is one of the strangest construction machines ever invented. Instead of using a bucket, a blade, or a hammer to dig into the ground, this machine literally sucks the earth up. With a giant industrial vacuum hose mounted on a truck or tracked carrier, the suction excavator removes soil, gravel, sand, mud, and even debris by inhaling it into a sealed tank. It looks like a mix between a fire engine, a leaf blower, and a factory dust collector. But its unusual design solves problems that normal excavators simply can't. The secret behind its power is the enormous fan or air pump system inside the machine. These fans create extreme airflow, sometimes more than 40,000 cubic feet per minute, strong enough to pull loose material straight through the hose. Operators use a long, flexible nozzle to direct the suction, often maneuvering it like a giant vacuum wand. When the machine is running, you can hear a deep, roaring hum as dirt vanishes into the pipe and disappears into the storage tank. Why go to all this trouble when a normal excavator could dig the same hole? Safety. Suction excavators are used when underground utilities are nearby. Gas lines, fiber optic cables, water pipes, or electrical conduits that could be damaged by a traditional digging bucket. Instead of tearing into the soil blindly, the vacuum gently removes earth without applying direct force to buried infrastructure. This process, called soft digging, has saved countless utility networks from costly and dangerous damage. The machine is also used in tight urban spaces where large excavators can't fit. A vac truck can park along a sidewalk, drop its hose into the ground, and dig a precise hole only a few inches wide. Construction crews like it for foundation repairs. Landscaping contractors use it to expose tree roots safely, and road crews rely on it for clearing debris from drains or cleaning out manholes. Some suction excavators are mounted on wheeled trucks, while larger models sit on off-road carriers with stabilizing legs. The biggest units can suck up rocks the size of footballs, mud from flood zones, or even liquid slurry from broken water mains. Once its tank fills up, the machine simply drives to a dump site, tilts the tank, and empties the contents like a giant mechanical stomach. It may look odd and sound even stranger, but the suction excavator has become one of the safest, cleanest, and most precise digging machines in modern construction. Proof that sometimes the best way to move dirt is to vacuum it. The trenchless horizontal drill, a burrowing machine that works blind. The trenchless horizontal drill, often called an HDD, horizontal directional drilling machine, is one of the strangest and smartest construction vehicles ever invented. Unlike normal excavators that rip open the ground from above, this machine burrows underground, carving a path for pipes, cables, and conduits without digging a trench. It disappears beneath the soil, travels sideways like a mechanical mole, and creates underground tunnels while operators guide it from the surface. To people watching, it looks like the machine is working blind, drilling underground where no one can see. But in reality, it's performing one of the most precise jobs in modern construction. The machine begins by drilling a pilot hole. A long steel drill rod, tipped with a sharp drill head, is pushed into the earth at a shallow angle. As it advances, high-pressure drilling fluid, usually a mixture of water and bentonite clay, flows through the rod. This fluid lubricates the drill, cools it, and carries loose soil back to the surface. The drill head itself is asymmetric, allowing operators to steer it by rotating or holding it steady. Using this method, the machine can turn left, right, climb upward, or dive downward, tracing a curved path underground. The strangest part, The operators guide the drill even though they never see it. They rely on a tracking system buried inside the drill head. Sensors measure its depth, angle, and direction, sending data to a handheld receiver or a computerized guidance system above ground. A technician walks along the expected drill path, monitoring the signal to ensure the drill is exactly where it should be. With practice, crews can steer the drill within inches of the target, even hundreds of feet below the surface. Once the pilot hole reaches the exit point, the drill head is removed and replaced with a reaming tool. This reamer widens the hole, making space for the pipe or cable. Finally, the pipe is attached to the drill string and pulled back through the underground tunnel as the machine reverses its drill rods. The result is a perfectly installed pipeline without tearing up roads, sidewalks, rivers, or landscapes. This technology is essential for modern infrastructure. It allows contractors to run fiber optic cables beneath cities, install water and sewer lines under busy highways, or bury electrical conduits without shutting down traffic. It prevents erosion, protects sensitive environments, and saves millions in restoration costs. The trenchless horizontal drill may look like a small rig on the surface, but beneath the ground it performs magic, quietly carving tunnels, navigating blind, and building the infrastructure that keeps modern life running. The road zipper machine, the vehicle that moves highways. The road zipper machine, also known as a barrier transfer machine, is one of the strangest, smartest, and most crucial traffic management vehicles ever created. At first glance, it looks like a long armored bus driving slowly down the highway. But watch it in action, and you'll see why it's considered one of the weirdest machines in modern construction. It literally moves the road. By lifting and shifting concrete barrier walls in real time, the road zipper can change the number of lanes on a highway, while cars are still driving next to it. The concept sounds absurd, but it solves a major urban traffic problem. Cities often have highways where one direction gets crowded in the morning, toward downtown, and the opposite direction gets crowded in the evening, leaving downtown. Instead of building more lanes, expensive, disruptive, and often impossible, engineers created a mobile machine that can zip the center barrier back and forth, giving extra lanes to whichever side needs them most. And it does this every day, sometimes twice a day, without shutting down the road. Here's how it works. The concrete barrier in the middle of the road isn't one solid piece. It's a chain of interlocking segments shaped like giant puzzle pieces. The road zipper drives over these segments, pulling them inside an S-shaped conveyor system. Inside the machine, powerful hydraulic arms lift each barrier piece a few inches off the ground. Then, the conveyor shifts the pieces sideways, often by 8 to 24 feet, before lowering them back onto the road. To drivers, it looks like the entire wall is magically sliding across the highway. The process happens continuously as the machine moves forward, usually at 5 to 10 miles per hour. It can reposition an entire mile of barrier in just 10 to 15 minutes. Watching it work is almost hypnotic. The barrier snakes along the ground like a giant concrete zipper being pulled across pavement. The road zipper isn't just clever, it's incredibly safe. Because it isolates traffic flows, it reduces head-on collisions in construction zones and high-speed areas. And by giving lanes to the side of the highway that needs them most, it reduces congestion without widening the road. Cities like San Francisco, Sydney, New York, Miami, and Auckland rely on these machines every single day. Despite its bizarre appearance, the road zipper machine is a traffic superhero, a slow-moving, lane-shifting, concrete-lifting vehicle that changes the shape of highways in real time. In the world of weird construction machines, there's nothing else quite like it. The Amphibious excavator, a swamp machine on floats. The Amphibious excavator is one of the strangest-looking construction machines ever built. Part excavator, part boat, and part oversized marsh creature. Instead of sitting on steel tracks like a normal excavator, this machine rides on giant floating pontoons, allowing it to operate in places where traditional equipment instantly sinks. swamps, wetlands, flooded plains, deep mud, mangrove forests, and riverbeds. These are the amphibious excavator's natural habitat. It is designed to go where no other construction machine can survive. The secret behind its bizarre shape lies in its pontoons. These long, hollow, reinforced steel floats act like giant boats, spreading the machine's weight across a huge surface area. This reduces ground pressure so dramatically that the excavator can crawl over mud so soft it behaves like pudding. On deeper water, the pontoons provide partial buoyancy, allowing the machine to float walk across swampy terrain while remaining stable enough to dig. Some models even come with additional hydraulic side pontoons for extra flotation in deeper channels. From the operator's seat, however, the amphibious excavator works just like a normal one. Its boom, stick, and bucket perform all the same tasks: digging, dredging, scooping, shaping, and clearing. The difference is that it does all this while partially floating. The long reach of the boom allows it to dig out silt and sediment from underwater without risking rollover, which makes it invaluable for river restoration, coastal defense work, flood control, and marsh rebuilding. The tracks are also unique. Instead of steel pads bolted to a standard undercarriage, the amphibious excavator uses wide, paddle-like track shoes mounted directly on the pontoons. These grip into mud and soft soil without sinking, functioning almost like fins. Some models include hydraulic drive motors inside the pontoons, giving the machine surprisingly good maneuverability despite its bulk. One of the machine's biggest strengths is environmental sensitivity. Wetlands are fragile, and bringing conventional heavy equipment into them can cause massive ecological damage. But the low ground pressure of an amphibious excavator allows crews to clean waterways, remove invasive plants, restore marshes, or repair levees without tearing up the environment. This has made the machine a key tool in coastal restoration programs in Southeast Asia, the United States, and Europe. Even after years of slogging through mud and water, amphibious excavators remain incredibly reliable. As long as the pontoons stay sealed and the drives are maintained, these swamp machines can keep working in conditions that stop every other vehicle in its tracks. Strange, floaty, and unstoppable, the amphibious excavator is the ultimate swamp survivor, a construction machine that literally walks on water. The walking harvester forest spider, a tree-cutting, six-legged robot. The walking harvester, often nicknamed the forest spider, is one of the weirdest, most futuristic forestry machines ever built. Instead of wheels or tracks, this machine stands on 6 hydraulic legs, allowing it to walk, climb, crouch, lean, and balance like a giant mechanical insect. Designed for logging in extreme terrain, mountain slopes, rocky forests, loose soil, wetlands, and areas unreachable by normal harvesters, the forest spider looks more like a sci-fi robot from a movie than a real piece of forestry equipment. Yet, it's fully real, fully functional, and shockingly capable. Built by specialized engineering firms like Menzie Muck and Kaiser, walking harvesters were created to solve a deadly problem in logging: steep terrain. Traditional wheeled machines slip, sink, or roll on slopes greater than 30 degrees, but the forest spider doesn't drive over terrain, it grips it. Each leg can extend, retract, rotate, and brace itself independently. This gives the machine the ability to perch on cliffs, straddle boulders, and climb slopes where even humans struggle to stand. At the core of the machine is a powerful processing head mounted on an articulated boom. This head can grab a tree, cut it at the base in seconds, strip its branches, and slice it into perfectly measured logs. The forest spider can perform all of this while clinging to mountainsides, balancing itself automatically using sensors and hydraulic stabilizers. Operators describe the experience as piloting a metal mountain goat. The machine's walking system is its strangest and most impressive feature. When moving, the forest spider plants its legs one at a time, shifting its weight like an insect. It can crouch low to crawl under branches, lift itself high to step over obstacles, or widen its stance to stabilize on loose slopes. Some models even float on water by spreading their legs wide. turning into temporary amphibious machines. Beyond its weird appearance, the walking harvester offers surprising environmental benefits. Normal forestry equipment tears up fragile terrain, causing erosion and soil damage. But the forest spider places its feet gently and only where needed, minimizing ground disturbance and protecting forest ecosystems. This has made it a preferred machine for selective logging, reforestation, and operations in protected environments. Despite being incredibly advanced, walking harvesters are amazingly durable. Many early models built decades ago still operate today, their hydraulic limbs proving tougher than expected. A tree-cutting robot with 6 mechanical legs, able to climb mountains and cling to cliffs, the forest spider pushes the limits of what heavy machinery can be, proving that sometimes the weirdest designs are the most effective.